Hello everyone, welcome to my channel. I do educational material on this channel, mostly things that you would classify as theories of everything, all-encompassing theories that attempt to explain how things work in this universe. And we are embarking on episode number 230 on the reciprocal system of theory. And the reciprocal system of theory is a system of theory, or a theory of everything, that was first derived by Dewey B. Larson back in the 20th century. And he started his work way back around 1930 and continued it for 60 years until he died in 1990. Since then, some of his associates and his followers have kept at it and attempted to work out some of the bugs and have done a great job as well. So we're going to be looking at one of those people today, Dr. Bruce Perret, who is writing also under the pen name of Daniel Phoenix III. And we're looking at one of his articles that is called Geochronology, which is the first installment of his anthropology series. The basic idea behind the reciprocal system is that this universe is a universe of motion. It's not so much a universe of matter or a universe of energy, but it is a universe of motion. Matter and energy are merely two different varieties of motion, along with acceleration and speed and pressure and electric charge and electric current and magnetic flux and viscosity and fluidity and density, and there are many, many others. They are all motions, and motion is the relationship between space and time. All motions are fractions that have either time or space as the numerator, and either space or time as the denominator. But it is a little more complicated because space and time both come in multi-dimensions. So you can have time to the third power, or you can have space to the third power, or space to the second power, and so on. So there's more permutations than just simply space over time or time over space. Space over time is speed. The car is moving 15 miles per hour. 15 miles of space and 1 hour of time. Time over space is energy. It took me 30 minutes to move that thing 2 feet. That is energy, time over space. But then there are also things like acceleration. I dropped the ball out the window and it fell at 9.8 meters per second squared. That is space over time squared. Acceleration. The kind of inverse of that would be force. Force is time over space to the second power. And then we have relations like matter. Matter is time to the third power over space to the third power. So this serves as a great way to check your work, and it also serves as a great system of units, because you only have two of them. There's only time and space. There are no other units that enter into the picture whatsoever. So this is a powerful tool among a number of powerful tools within the reciprocal system. Larson wrote in about the late 1950s, he put together his fundamental postulates, and there were two of them, but really the first one is the most important. And the basic idea is that, you know, the universe is made out of motion. Motion is the relationship between space and time. Space and time have three things that they have in common as reciprocals of each other. They are both coordinate space and coordinate time, meaning that they have three or more dimensions, x, y, z coordinates. They both have their scalar aspects, which Larson calls clock time and clock space, meaning that they have a motion, but it has no particular direction. And you visualize that using a balloon and a magic marker that puts dots on the balloon. You blow up the balloon, all of the dots are moving away from each other. You suck in the balloon, all of the dots are moving toward each other. That is an outward scalar motion and an inward scalar motion, respectively. And that is what Larson calls the clock. The clock time, it's always getting later and later and later, but again, in no particular direction. And clock space, things are always getting farther and farther and farther apart. It's an outward scalar motion, the flow of space or the progression of space. And then time and space also only come in discrete units. There is a minimum unit of space and a minimum unit of time. Those minimum units are very, very small, so we can't quite resolve them. We can't, you know, they look continuous to us, just like a cartoon that is, you know, showing us 100 frames per second or whatever. We can't resolve the difference between one frame and the next, but they do exist. And if we go within one unit of space, then there is no space, there is only time. Larson calls that the time region. And if we go within one unit of time, there is no time, there is only space. And Larson calls that the space region. So the space region is within what Larson, and the last part of that is that one unit of space in one unit of time is the speed of light. So the speed of light is 1. Larson calls that unit speed. And 1 is the midpoint in the reciprocal system. Everything above 1 is what Larson calls the cosmic sector, faster than the speed of light motion. And whatever is below 1 is what Larson calls the material sector, slower than the speed of light motion. And this is the region, the material sector, that the scientists are aware of. And that's why Einstein said that nothing moves faster than the speed of light. So we know much about the material sector and very little about the cosmic sector. But another powerful tool in the reciprocal systems bag is that the reciprocal postulate will show that what goes on in the cosmic sector is the exact same as what's going on in the material sector, except that the roles of space and time are reversed. In the material sector, you have coordinate space and clock time. We are familiar with those. 3 dimensions of space and a progressing time, always getting later and later and later. In the cosmic sector, we have the reverse of those roles in space and time. We have coordinate time, 3 dimensions of time, and clock space. Space is always getting farther and farther apart. So that is just one way where you can show how the roles of space and time are reversed when you cross that unit speed boundary. So there basically are 3 unit boundaries here in this reciprocal system construct. There is the unit speed boundary between the material and cosmic sectors. There's the unit space boundary between the material sector and the time region. And then there is the unit time boundary, which is between the cosmic sector and the space region. Okay, Now we're going to go into Daniel's paper here. We're at a section, I believe this is the 6th episode that we've done on this. So if you want to go from the beginning, go back about 5 episodes. But here we're going to start with a section that's called Sister Worlds, the Inner Planets, or the Yin planets. Yin is in. Yin planets are compressive, resulting in hard, rocky surfaces that crack over time as their cores cool and expand. This is observed as tectonic plates separating continents on Earth and hills and fracture zones on the other hard planets and moons. These fracture zones and areas of upheaval are indications that there is a white dwarf fragment at the core of the structure that is gravitating in time and, due to the reciprocal relation, expanding in space. However, without an oriented magnetic field, the early planets would be subject to exposure of all sorts of ionizing radiation and mass ejecta from the sun, which tends to inhibit, not stop, the development of life. Early forms of life on these worlds will either be resistant to radiation or make use of it as a kind of food source, similar to plants eating light through photosynthesis. Once a situation develops where a magnetic field becomes oriented, the resulting strong magnetic field deflects these damaging effects from the sun, and an explosion of life occurs on the planet, as what occurred on Earth during the Cambrian period of the Paleozoic era. This situation occurs when the planet obtains a moon. Initially, the inner planets were in a gravitational lock with the sun. Like our present-day moon, the same face was always pointed at the sun, providing a light side and a dark side. Even now, Mercury and Venus barely rotate on their axes. Mercury's day is longer than its year. Mercury's day is really precisely, or very, very close to precisely, twice as long as its year. This results in a dichotomy of heat and cold, with the face toward the sun getting exceptionally hot. The dark shadow side, due to little or to no atmosphere, will be almost as cold as the surrounding void of space. The thermocline, where hot meets cold, tends to be an area of stress and shear, cracking the young planet around its girth in great and yawning voids. Consider this Norse creation myth. The first realm to exist was Muspel, a place of light and heat whose flames are so hot that those who are not native to that land cannot endure it. Beyond Muspel lay the great and yawning void named Ginnungagap. And beyond Ginnungagap lay the dark, cold realm of Niflheim. Consider it to be a description of the early inner planets, with the burning hot side facing the red giant sun, a temperate region around the edges where the sun is low in the sky, and the eternal black cold and darkness of the side facing away from the sun. Again, the yang boundary yin structure, with the Norse equivalents being Muspel, fire, Ginnungagap, the great gap, and the Niflheim, ice. The sister worlds of Mercury, Venus, Earth, and Mars originally looked very similar: dried out balls of rock and volcanoes, cracking their surfaces as the cores expand, with an inverse density gradient, putting the heaviest elements near the surface. Not much good for the formation of life, at least not yet. The ancient records described things we could not possibly know about, but the gods did know. Gods with a small g. But the gods did know, relating to us through mythology and apocrypha. Okay, this section is called Brother Worlds, the outer planets. The outer planets, being the larger, more energetic fragments, will initially be dark bodies emitting X-ray and gamma radiation, part of their transition from solar to planetary status. As they cool, they will produce significant amounts of visible light, like miniature suns, starting with the most energetic, the outermost planet of Neptune, and moving in quantized steps inward. In essence, they behave like their larger cousin, the nova, as the cooling process will produce light elements that gravitate toward their centers, including hydrogen and oxygen, the unexplosive combination. And eventually, they do go off with a bang, scattering dust, rock, and planetary chunks into nearby space, typically along the equatorial plane, which produce a series of icy moons and rings, much like the supernova that created the planets and asteroid belt. Again, it is the same process, just a different scale. After their blaze of a nova subsides, they will have large atmospheres of light elements with a ring system and a number of moons scattered about. If the explosion is energetic enough, some of these moons may reach escape velocity and go wandering to the outer solar system, anti-gravity motion, and to take up unstable orbits further out. The sequence of events in the ancient sky, because of quantized transition and remembering that all the planets share the same core in 3D time, will be that when one planet drops in energy, the next lights up, a kind of stair-step effect. Okay, I'm just trying to check these footnotes to make sure there's nothing too important in here. Okay, as a result, there will be a dominance of brilliant star-like planets in the sky. At first, no visible planets, but point source X-ray and gamma ray sources are detectable where the planets will form. They are already there, just not emitting or reflecting light. Neptune flares. The other planets are still dark. X-ray bodies are still dark X-ray bodies. At this time, the planetary orbits of both inner and outer planets are much closer to the unit speed boundary, the asteroid belt, and are just now beginning to spread away from it. Neptune dies down to a planet with a ring system. The lower speeds move the planet into a more distant orbit. Uranus flares up and becomes dominant in the night sky, with Jupiter and Saturn still being dark bodies. Then Uranus dies down from the same conditions and Saturn becomes active, leaving only Jupiter a dark body. Then Saturn dies down and Jupiter flares up, becoming the dominant object in the sky. Jupiter dies down to planetary status. By this time, the planets have lost most of their anti-gravity motion, their orbital velocities have reduced, and they are in orbits much further apart from each other, but also will have moved closer to the Sun. The Sun has been condensing all along and getting smaller and brighter, heading toward the main sequence dwarf. This is the current structure of the solar system. It has changed significantly since its formation. Note that the sequence of bright star-like objects in the sky, a natural consequence of reciprocal system astronomy, matches the mythological ages, or suns, as the Aztecs say, or the domination of certain titans, Poseidon being Neptune, Uranus as Uranus, Cronus as Saturn, and Zeus as Jupiter in the Greek. The changing dominance of these very obvious planetary lights in the sky plays a significant role in mythology, as the planetary orbits also change when the ruler of the sky, so to speak, changes. For example, when Jupiter became dominant over Saturn in the sky, the orbit of Saturn moved further out, and the ring system could no longer be seen. Zeus, or Jupiter, overthrew his father, Cronus, or Saturn, who overthrew his father, Uranus, or Uranus. There is a mythological pattern that mimics the consequences of reciprocal system astronomy. The inner planets have not changed much, other than to slow down and move closer to the Sun, as the core sizes are too small to sustain the drastic exhibitions of the outer planets. The occasional core flare will crack their surfaces and cause sudden expansion. Magnetic ionization levels were initially very high because the core is a stellar fragment and decreases as the planetary core ages. Rather than a solar transition up to a higher magnetic ionization, the planets do a planetary transition down to a lower magnetic ionization. This infers that much of the material on the early planets was radioactive, and as the planets age, their minerals become less radioactive. Now, the concept of magnetic ionization is that every planet, every star has an ionization level, which is quantized. And it basically means that if your ionization level is 0, then all of the elements are stable on your body, on your planet, or your sun. So in Larson's system, there are 117 different elements. All of them are stable at ionization level 1, or 0. But if you move to ionization number 1, which is where Earth is, then only the elements below uranium, element number 92, are stable. All the rest of them are, those other 25 of them are radioactive. Then if you move to a planet with ionization level 2, then it's gold. Element number 79 is the largest stable element. All of the other elements, 38 of them, are unstable at that environment. And as you move further down, Larson has an equation for this, but as you move all the way down, all the way to, ionization level 14 or 15, you get down all the way below element 50, down to about element 40 something, niobium. And that is the heaviest stable element at that level. So that's kind of what Perret is talking about here. Okay, now we will stop there, and I think he actually explains this here, but we will start with that tomorrow. And thanks for tuning in. Hope to see you tomorrow, and have a great day.